All right, you have 6 whole problems for this section, and they can all be done on your calculator like we did on the last section. So I'm just going to help you set them up. A car leasing firm must decide how much to charge for maintenance on the cars it leases. After careful study, the firm determines that the rate of maintenance, so remember a rate of change would be the derivative, so the rate of maintenance, m of x, on a new car will approximate m of x equals 41 times 1 plus x squared dollars per year. X is the number of years the car has been in use. What total maintenance cost can the company expect for a 2-year lease? Okay, so first of all, what's the rate of change? The rate of change is a 41 times 1 plus x squared dx. Okay, I want the first 2 years. So I've got year 0, year 1, and year 2. Okay, so I'm integrating from 0 to 2, and then this is my integrand. So the total maintenance cost that the company can expect on a 2-year lease means we're going to shove this in at math 9. We're going to go from 0 to 2 of 41 times 1 plus x squared, and then close that parentheses, and then dx. And I get 191.33. Okay, so that is the total cost over 2 years is 191.33. So what's the amount I should put on the monthly lease payment just to kind of sort of spread it out? So if I'm doing this for 2 years, but I'm talking about months, how many months am I doing this for? For 24 months. So if I take this maintenance cost and divide it over 24 months, I get $7.97. So if I add that amount to every month's lease payment, then the maintenance costs will be covered at the end of the lease term. All right, so a company is considering a new manufacturing process. It knows that the rate of savings, in other words, the derivative, is 4,000 times t plus 5. And again, we don't care about t's or x's, whatever. We're just going to use x. So t is the number of years the process has been in use. Find the total savings during the first year. So for the first year, we're going to go from 0 to 1, and I'm going to go ahead and change that to an x, and then dx. So from 0 to 1, hit math 9. Your limits of integration are from 0 to 1 of 4,000 times x plus 5. Close that parentheses, dx. Okay? I really wish you could see this better. Ooh, look at that. Okay? So hit enter, and we get 22,000. So the total savings in the first year is $22,000. Hang on. I'm making sure it's not tricking me like with millions or something. All right, so what's the total savings during the first 8 years? Well, if the first year is from 0 to 1, then the first 8 years must be from 0 to 8. So I'm going to put everything's the same except for my upper limit of integration is now an 8. So my total savings should be $288,000 over the course of 8 years. Okay, so the next one. All right, so my t value is between 5 and 16. So they gave me a partial. So my lower limit of integration is 5. Well, what's the upper limit? It's 16. Okay, what is my function? So the rate at which revenue is generated can be approximated by this equation. So that is your derivative. So we've got a negative 1.38 t squared plus 34t minus 119 dt. Okay, what's the total revenue generated to the nearest billion between the start of 2005 and 2016? So if t equals 5 corresponds to 2005, then that's where this 5 came from and that 16 came from, because that's 2005 to 2016. So all we got to do is slap this thing in here. So we have math 9. We are going to go from 5 up to 16. And again, your calculator does not care about t's. So 1.38x squared plus 34x minus 119 gives me dx, gives me 791.34. So 791.34 billion. So to the nearest integer is 791 billion. All right, so the last couple, we're going to find area between two curves. So I am looking at an x equals -2 and x equals -1. Those are vertical lines. Okay, so I have x equals -2 and x equals +1, and those are my limits of integration. The two functions I'm messing with are y equals x, which is a diagonal line, and y equals x squared minus 2, which is a parabola that goes like this. Okay, if we graph this in our graphing calculator, so what I have is y equals x on y1. Okay, and then this is so hard to see, my goodness. Okay, and then y equals x squared minus 2 on y2. Okay, so what I want to do is watch the graph. So the blue thing is y equals x. The red thing is the parabola, and I am trying to find the area between -2 and +1. So the issue with that is if you'll notice, -2 is to the left of where the parabola is. So your question is going to be this: which picture is on top? So up here is top, down here is bottom. Okay, so from here, from an x value of -2 until I hit -1. Okay, so from an x value from -2 to -1, the parabola is on top. Okay, from -1 to +1, the line is on top. So literally, if you're just kind of sort of skating this thing down, right now when I compare the parabola to the line, the parabola is on top, the line's on bottom. But from -1 to 1, sorry, the line is on top and the parabola is on bottom. So we're going to have to add together two different things. So what we do first is you always do top minus bottom. Okay, so I'm trying to go from -2 to +1. I know my first setup is going to be from -2 to -1, because in that setup, the parabola is above the line. Okay, so what I'm going to do is parabola, which is x squared minus 2, and then subtract off the line. So minus the line. Okay, so yes, so x squared minus 2 minus x dx. To that area, I want to add some more area. Okay, so I'm going to go from -1 to 2. Ooh, that's a lie. From -1 to +1. So this is -2, that's -1, that's 1. And I'm going to add up -1 to 1. Well, from that section, the line is on top and the parabola is on the bottom. So I need to do line minus parabola, which when I distribute that negative, will give me x minus x squared plus 2 dx. Okay, and you can just enter that entire thing in your calculator. So what we're going to do is hit math 9, and then we have the lower limit is -2, the upper limit is -1 of parabola minus 2 minus line, so parabola minus line, and then dx, and then just hit plus, and then math 9, then I'm going to do line minus parabola. So I've got -1 to +1 of x minus x squared minus 2. That's a lie. It is plus 2 dx. So when you look at this thing, I've just got it spelled out all the way across the bottom. There it is. You can see it now. Okay. So that whole thing across the bottom, and I can hit enter, and it tells me 5.16666, or I can hit math, enter, enter, and it changes it into 31/6. So your total area, which would be this stuff plus this stuff, is going to be 31/6. Okay, so let's try another one. This one's easier. Okay, so I've got the area between y equals x and y equals x squared. So if I've got y equals x, it's just a line. Y equals x squared is a parabola, and I'm just going from 0 to 1/2. So which graph is above the other? I'm going to have line minus parabola. So my limits of integration are from 0 to 1/2 of the line is on top minus the parabola is on the bottom dx. Okay, and so that one if you just know the basics, we didn't have to figure out anything weird because there wasn't two different setups there. The entire area that I'm interested in has the line above the parabola. So math 9 is going to give me from 0 to 1/2 of x minus x squared dx. And when I get that, I got 0.0833333, which gives me 1/12. Okay, so can you see that? Look at that, it's so pretty. Okay, so you get 1/12. All right, the last one, again, this one, you don't know what the graphs look like off the top of your head, so I'm going to go ahead and graph these ones. So it says, use a graphing calculator to approximate the area between the graphs of the natural log of x. So I'm going to do natural log of x, okay? And then 8x times e to the x. Okay, so those are the two graphs that I'm interested in. Can you see that? There you go. All right, so that's what I want, and now I'm going to hit graph. And if your graph looks weird, then just hit zoom and choose option number 6, and that'll take you, and it'll standardize it out. All right, so the blue thing is the natural log, and the red thing is the 8x times e to the positive x. I'm only interested in what's between 1 and 2. So here's 1. Can you see it? And here's 2. So noting that, the red thing is on top, and the blue thing is on bottom. And it doesn't overlap itself or anything like that. So all we have to do is go from 1 to 2 of the top function, which is 8x e to the x, minus the bottom function, which is the natural log of x, dx. And that's your setup. Okay, so when we go put this out here, we've got Math 9. And then I'm going to go from 1 to 2 of what was the top function, 8x e to the x, minus what's the bottom function, the natural log of x. Close that parenthesis, otherwise it'll screw up. Okay, dx. And that is going to give us 58.726. So to the nearest hundredth is going to be 58.73. So 58.73. And that is that section.